Assalamu alaikum. Welcome to yet another very interesting lecture on software quality assurance. In the last lecture we were talking about SQA reviews, and we looked at different kinds of reviews, from business reviews to management reviews and technical reviews. We also discussed how a review is conducted, what are the roles played by the participants, what are the responsibilities of each role. We also mentioned that inspections is a form of review. And throughout the semester, you have heard me say this many times, and I'm sure you have read this in books all the time, that software inspections are a very effective technique for removing defects. In fact, we say that software inspections are the best technique to remove software defects. We haven't really made the case on using software inspections. So starting today, we will be talking about software inspections. I will be making the case today, introducing you to what inspections can do, and then we will continue on with this discussion in lectures to come. So what is an inspection? An inspection is a rigorous team review of a work product by peers of the producer of the work product. So we have two conditions. Number one, it's typically done by a group. Number two, it is performed by peers or colleagues of the person whose work product is being reviewed. The size of the team varies on a number of factors. It depends on the kind of work product, the size of the work product, and the degree to which we want to rigorously review it. So inspections are typically done by a team of peers. It is important to highlight the fact that the inspections are performed by peers, because peers and colleagues know both the application domain and the technology that is being used to develop a software solution in that application domain. So this is an important precondition or important characteristic of software inspection. The primary purpose is to find defects. We record defects as a basis for analysis on the current project and for historical reference for the future projects. So that is that first of all we try to find defects. That is typically the only purpose of having software inspections. We record those defects so that we can learn them throughout the current project as well as in the future projects. This inspection process is an example of direct fault detection followed by removal. We have talked about this concept a little bit earlier in the semester, that inspections represent or are used for direct fault detection followed by removal, while software testing is used to observe failures in software, and then we try to remove the symptoms. We try to remove the causes of the failure of the software system. Studies have shown that software inspections are most effective when they are performed immediately after the work product is complete. That is, before further development can be done using that work product. So typically we can say that if we follow a software development life cycle, these inspections will be very effective before we transition into new phases or new activities. That is, if we are going to inspect requirements document, that would be best done before design activity starts, because in that way our requirements document will then be foundation for the design activity and the design process. And similarly, the design document and software design can be inspected before code writing begins. And so if there are any errors in those documents, we can remove them, and and the errors contained in those documents do not have to be included in the activities downstream. Now this is ideal. We can, however, inspect any work product at any time, whenever that is deemed ready for inspection. Obviously, we do not want to inspect a half-cooked document or half-complete document. So the point that I'm trying to make is that the importance of inspections is such that although the inspection process is most effective if performed at a level where there is some comfortable level of completeness in that work product, but even if it is not complete, the inspection process can be executed. If you analyze inspections, inspections are basically critical reading and analysis of software work product. Those work products can be any form of software artifacts. Most successful defect removal for software code and design defects have been inspections in the last 30 or so years. However, inspections can and should be applied to requirements documents, to product specifications, to test plans, to test cases, and even user manuals. The same can be said about using software inspections on project plans, on software quality assurance plans, on software configuration management plans. But the level of detail and the level of rigor would change, and the perspective may also change. They may be called reviews. But if you want to find defects in SQA plans, in our software configuration management plans and software project plans, then applying software inspections is not a bad idea. As I have said before, that typically inspections are conducted by multiple human inspectors through some coordination process. Multiple inspection phases or sessions may also be used, as we have seen in the case of reviews in the last lecture. That if a product contains severe defects, multiple review sessions may have to be conducted. The same goes with inspections. We have said this before in another lecture, and I just repeated it here today, that faults are detected directly in inspection process. This can be done in two ways. Either when the inspector is individually going through the work product, or in a collective session when the inspection meeting is going on, in the group session. Identified faults need to be removed as the result of the inspection process, and their removal also needs to be verified. This thing is similar to the discussion we had on the reviews. The process of inspection typically includes some sort of planning, before the inspection meeting is held, and is followed by a follow-up set of activities in addition to that meeting, that core inspection process or activity that is a group session. Companies over the years have modified their inspection process according to their specific needs, and they have made improvements to them in areas where they deem necessary, and this depends on the kind of application that they are working on, the company culture, and many other factors. However, for individuals and companies who want to start the inspection activity, it is advisable that they follow the inspection process as recommended, or it's in the original form. Basic training to inspectors and managers should be provided so that they can understand the importance of conducting software inspections in the right way. Inspections were developed at IBM by Michael Fagan, and these inspections were reported in the research literature in 1976. That is, the world at large, or the software engineering community and computer science community at large, came to know about software inspections in 1976. However, the original work and original research was applied and was made company-wide public in 1972, and IBM performed software inspections in different projects from 1972 to 1976. Like any new idea, like any new process, like any new research, it took even IBM and projects within IBM it took them with surprise, and managers were not willing in the beginning to try software inspections. But as the inventors and researchers were steadfast and convinced the project managers, they used software inspections and were convinced of its results, of the benefits achieved by applying software inspections as a defect removal activity. And since 1976, many researchers, many practitioners, many academicians have used software inspections as a way to illustrate that defects can be detected earlier in the life cycle, and they should be used to eliminate software defects before we go into software testing. The whole idea of applying and using software inspections is to remove software defects at a reduced cost. Why do we so much worry about reducing costs in software defect detection? Because if you look at the historical data, software projects are becoming increasingly expensive. Economies at a large scale are now dependent on services provided by software. There was a time when hardware was expensive and software was cheap or cheaper. Things have changed now. Computer hardware is relatively very inexpensive. If you go back 10 years, or 15 or 20 years, and note down the prices of personal computers and the speed at which they processed applications, and you go to a market now and compare the computer prices, you will be surprised that the prices of computers and all electronic devices have nosedived in the last 30 or so years. And on the other hand, the prices of software applications have gone up. And so the research is focused on two ends. One is the technical side, and other is the management side, that techies are interested in removing software defects. That's it. Management is also interested in removing software defect to reduce the costs of the software product, to reduce the costs of software process, to reduce the cost of software project. Because defects introduced in software will definitely increase the cost of software. What inspections do is that they enable us to remove defects early in the software lifecycle. And I'll show you how. It is always cheaper to remove defects earlier in the lifecycle as compared to later in the lifecycle. And especially if the defects go to the customer and they find it, then it's even more expensive, as I will show you in a little while. So this is all about software quality. This is all about removing defects from the software product. In the very first lecture, we mentioned that our goal is to have 100% defect-free software delivered to the customer. But for all non-trivial software projects, we know that that is not possible. We know that in every software engineering activity, be that requirements or design or coding or others, we inject defects into the software product or software work products. We remove some of these defects when we are in the testing activity, when we are performing different kinds of software testing, unit testing, integration testing, acceptance testing, and others. We also know that all defects are not removed at shipment time. These defects are known as latent defects. These are the defects which sometimes are sometimes discovered by the customer. What we ideally want to do is to eliminate or at least minimize latent defects in the shipment of software products. It is expensive to find and remove defects in the testing phase, and even more expensive when the customer finds it. The problem is that in addition to the expense, there is also an embarrassment factor, because the customer may think that the development team has not done their work properly. And if the severity level of those defects, those latent defects, is high, then it's even more embarrassing. The customer may choose not to buy any further products from the vendor. What we can do is to minimize latent defects by by conducting the software inspection process. It'll help us reduce the defects in the product which is shipped, and will do it in a more cost-effective way. Let's now look at how defect removal is cheaper for inspections as compared to software testing. What happens is that during testing, defects are found. We know that. There is no disagreement on this. Now, when defects are found, these defects are given to the programmers. That is, the programmers are notified that certain failures have been observed. Go and find what the causes of these failures are. The programmers are going to take those, what we call as bug reports, and then try to recreate the same scenario. They will try to recreate the same circumstances in which those defects were detected or those failures were observed, rightly so. Once they are able to recreate those circumstances, they are themselves able to see the failures in the software product, then they will try to find what caused the failure. Because it is not obvious sometimes that when a failure occurs, the cause may be somewhere else. Failure occurs at point A, and the failure and the cause of that failure may be in a different work product at point B. Because software is all integrated, one thing leads to another. For example, if a programmer forgets to deallocate memory, that error can cause or trigger another set of errors somewhere else. And so programmers, once they get the bug reports, have to try to find where the defects are. Now, I'm sure once they find it, they'll fix the problem as quickly as possible. But remember, we are in the testing activity. We are in the testing process. So on the one hand, we are doing testing, and on the other hand, we are fixing defects. So technically, we are actually in two phases at the same time. What are testers doing at that time? It is anybody's guess. Now, the programmers fix the defects. They perform some basic regression testing in order for them to check if they had not accidentally introduced new defects while fixing the old ones. That is another problem. That is another burden on the schedule of the project. That is another burden on the funds, on the budget. So I talked to you about two things: reducing cost and reducing time. Now, when tests are used to find software defects, neither the budget is coming down, neither the cost is coming down, nor the schedule is being reduced. Now, the programmers have fixed the problem. Hopefully there are no regression tests, no bad fixes, but they have to ensure to some degree, spend some time doing it. Then they will inform the testers that yes, we have fixed this problem, go and test this again. Reintegration will happen of the software product. That takes time. Time is equal to money. Both are going up. Both are being used. And we will be, when the testing is finished, we will have spent more money and more time if we solely depend on software testing as a mechanism to remove software defects. On the other hand, if we were to incorporate inspections also, by no way means I am suggesting to not use software testing. I am saying use inspections as a pre-test mechanism of defect removal, and then use testing as an added check. And in that way, software testing would not cause a lot of excessive wastage in money and in time. Now, while we are in the inspection process, the inspection process is executed in the same life cycle activity which we are inspecting. As we have said before, that inspections should be performed when the work product is immediately ready. That is before we move on to the next life cycle activity. If we are successful and successfully able to detect defects in the inspection process, we have found those defects, number one, directly. We don't have to observe a failure. We know where the defects are. We don't have to look for causes. We exactly know where defects are. So that's the direct defect detection. And then we will fix them in the same life cycle activity. For example, if we are in the design process, design activity, and we have found some design defects in the design work product or software design, those errors that we have detected will be fixed before we start the coding activity, start the programming activity. So as a result, the cost of removing defects would be lower, the time spent would be much lower, and the possibility of introducing new defects will also be much lower. This results in substantial reduction in costs and overall substantial reduction in schedule. Now let's discuss some of the problems that occur if we let some of the latent defects go with the product to the customer, and as a result customer makes the discovery of defects. Let's consider that scenario now. In that case, the defect reports, bug reports will be sent to whichever activity they belong to. But in many cases, for example, if the defects are of design, are design defects, then they'll be sent to designers to fix the design artifacts. If we find that they are coding errors, then they are sent to programmers and so forth. But in many times we notice, in many projects, that the original development team is disbanded after the shipment of the software, after a reasonable time has passed and the software is in use. In that case, it is going to be even more difficult to detect the cause of failure, and it is going to be even more costlier to fix those defects, because they have to now learn, people who are maintaining the software application would have to learn about the application, have to understand what different artifacts are being used, they have to learn about the application domain, and so it is a lengthy and costlier activity. And it also results in many unplanned expenses for the software development company. And the embarrassment factor is always there. Customers have to deal with downtime, their users may be unhappy, and so there's a lot of things that can negatively impact the relationship between the customer and the software developer. Let's now look at the defect cost relationship that I've been talking about. Here you are seeing defect cost relationship as a chart. You have major defect removal area where there's pre-test defect detection and removal, then there is test defect removal, and then there's defect removal by users. And on the other axis you can see relative costs to remove a defect. It is interesting to note that if it costs 100 units to detect and remove a defect while we are in the pre-test phase, that is, we are using inspections and reviews or walkthroughs for defect detection and removal, then it costs 1,000 units while we are in the testing phase. And if we do the same thing with users, that is, we are in the maintenance phase, users are using the software and they find defects, that is going to cost 10,000 units. 10,000 units. That's a lot of difference between pre-test activity and into the maintenance. And even if you compare pre-test and test, there's an order of 1 to 10. This chart alone ought to convince you that pre-test inspections and reviews are a very good mechanism for software defects detection and removal. Now it is interesting to note that this relationship remains or has remained constant in the last 3 decades or so. That is, since the first time when research was reported at the beginning of the inspections, that this is the relationship of finding defects and the cost of finding defects with inspections and cost of finding defects at testing and cost of finding defects in the maintenance. As I said, that there are other costs involved when users detect defects. That includes downtime, lost opportunity, and embarrassment for the company. This 100 to 1,000 to 10,000 cannot be exact, but these ratios are almost maintained in the same way. To convince you, there is some published data that I can show you from different studies of companies in which comparison of inspection costs and testing costs have been made. These were independent studies, and so they use different units to report their results. However, the pattern repeats that the cost of inspections is much lower than cost of software testing and defect discovery in the maintenance phase. There are 3 charts. We will cover them one by one. So you can see reported cost relationship There are 3 companies listed for you: IBM, AT&T, and ICL. Then there is cost inspections, cost in test, and cost with customer discovery. So for IBM's first study, we have cost in inspections as $48 per defect. Cost in test ranges from $61 to $1,030 per defect. And if the customer discovers the same kind of defect, it is $1,770 per defect. For AT&T, cost in inspections is 1 unit, cost in test is 20 units. For ICL, it's 1.2 to 1.6 hours per defect for inspections and 8.47 hours per defect for testing. So these were the 3 companies. Let's look at the next 3 companies. We have again AT&T, JPL, and IBM, and these are different studies. For AT&T here we have 1.4 hours for inspections, 8.5 hours for test. For JPL it's $105 per defect in inspections and $1,700 per defect for cost in test. For IBM study 2, it's 1 unit cost in inspections. It is 9 times more if it is done in testing, and it is 117 times more if it is done while in maintenance. So you see, with these 2 charts you should be convinced. But I have more data to show you. We have 4 companies here: Shell, Thorn EMI, Applicon Incorporated, and Infosys. Here for Shell we have 1 unit cost in inspections, 30 units cost in test. For Thorn EMI we have 1 unit cost in inspections, 6 to 8 to 26 units in cost in test, and 96 units cost with customer discovery. With Applicon Incorporated we have 1 hour time for finding defects if we are using inspections. They have not reported the time spent if they are using software testing, but they have reported time for software defect discovery if the customers find it, or in maintenance it takes 30 hours. For Infosys, the numbers are better. For cost in inspection it's 1 unit. For cost in test it's 3 to 6 units. So these are very interesting data sets. Anybody who is not yet convinced on using or the effectiveness of using software inspections should be convinced by looking at these studies. These are independent studies. I've mentioned 10 of them here. These studies clearly report data from different companies that it is cheaper to detect and remove defects using software inspections as compared to software testing. This is evidence in the literature that inspections offer significant return on investment even in their initial use. That is, the investment is in the form of providing training. As I've said, even when we were discussing reviews, and even today, that these techniques are going to cost money in the beginning because they require that you change the way you do software. You change the way you do defect removal. You have to be trained to do these new things. If you don't follow the inspection process, probably you will end up worse off than using it. Now let's look at defects from another point of view. We have up to this point looked at defects from cost perspective. We have also mentioned a little bit about the schedule aspects of it. What we haven't yet looked at is that relating defect discovery to defect origin points. What happens? Think about it for a second. In a project with no software inspections, defects are injected in every software activity. They're injected in requirements, they're injected in design, they're injected in coding, they're injected in testing while we are doing bad fixes, when we are preparing user manuals, training manuals, and other things. So software defects are being introduced and injected into the software work products in all the phases. This is regardless of the fact that we are using inspections or not. This is going on. This is, as we said, to err is human. So we humans, albeit good IT professionals, are still introducing defects of one sort or the other. That's a given. Now what happens really is that if we are not using the inspection process, we don't detect them until very late in the life cycle. And when we are so much behind in detecting or discovering these defects, when we start discovering them, this becomes a chaotic activity. So as a result, we get what is known as a chaos zone. Now you can see, and this is a very important diagram. This is a beautiful pictorial representation of what happens in those projects which do not use software inspections or reviews of some kind to detect defects. You see, this picture or this diagram relates defect origins and discovery points without, and this is a situation where we don't have formal inspections. We have requirements defects introduced and they are detected in the maintenance activity. Then we have design defects uncovered in the maintenance activity. We have coding defects which are uncovered in testing. We have documentation errors which are being detected while we are in the maintenance phase. The errors introduced in the testing phase are also found in the maintenance phase. And the errors we introduce in the maintenance phase are also found in the maintenance phase. And so you carefully look at this diagram, you carefully look at this picture, and you are going to agree with me, you will agree with me that this is not a pretty picture. If you ask me about the picture, about the diagram that we have just seen, I would describe the situation as a mess. And many software projects are in that state. If only we were able to detect defects in the same life cycle activity, then we can eliminate this chaos zone and bring some sanity back to the project team and project management. The solution is to introduce software inspections. If we introduce software inspections, we can bring sanity back. We can get the chaos zone removed. Let's see. Here you have a similar picture, similar diagram, and the heading will tell you that the relationship exists between defect origins and discovery points with usage of formal inspections. So we are using formal inspections. If you look at the top line, it says defect origin. The bottom line shows defect discovery. We perform the requirements processes. We have good formal inspections on requirements. We remove a large number of defects before we enter into design. The design is built on a high quality set of requirements. We perform inspections on design products, design activity, design artifacts, we remove defects, we make the changes, and we build software code on a high quality software design. We exercise the practice of code inspections before testing, that is, and we detect the coding errors, the programming errors, before we subject our programs to testing. And we do our documentation, we process the documentation through inspections, we detect all those errors which were found in the documentation, we remove them. We conduct our testing, we write our test cases, perform testing. I'm not saying we don't perform testing while use of inspections, but we do testing and we detect as many errors which are left even after inspections. And then we go into the maintenance life cycle, which is itself a complicated life cycle. And we don't have a chaos zone. We are not dealing with requirements errors, we are not dealing with design errors with the intensity that we were dealing if we were not using software inspections. Of course, here and there we'll find changes, we'll make improvements, we'll have perfective maintenance, we'll add new features, we'll modify some features. But by and large, our defect removal efficiency will go up significantly with the use of formal inspections. So you have seen that the chaos zone is gone. This is achieved by performing inspections on work products before leaving the life cycle activity, and as a result, large number of defects will be removed within that activity, and they will not cause the following or downstream processes to include those defects. And as I had said, the defects will sort of then become a snowball effect. That effect will be eliminated from software development lifecycle. So here you are, I'm sure, convinced that inspections work, and they do work. There's no doubt about it. So the question is, why isn't everyone using it? Why isn't every company, every software professional using some sort of reviews or inspections? I tell you that individually many people are using informal reviews, but by and large many companies are not using it. Reasons for not using software inspections include that there is resistance to inspections because people think that they are a difficult process. They are not easy to do. Management oftentimes think that they are an added cost. I agree, and researchers and people promoting inspections agree that there is a little bit of cost, upfront initial cost, in the training involved in initiating the process of inspections in a company. But overall, you have seen the data, both in terms of finances and in terms of schedules, that inspection reduce cost during a project. The development of new tools and IDEs force people to think, or they falsely think, that if we use these new tools and IDEs, we will not make any mistakes. That's not true. We recommend that IT professionals should use these environments and tools, but they are not going to eliminate the defect injection process. And certainly, inspections will help them remove those defects and save money and time. Another thing is that inspections are not the most enjoyable engineering tasks compared to design and coding, but they work. They work in finding defects. That's the purpose of their usage. Inspections are labor intensive and low tech, and many times programmers don't want to use inspections because they don't want to share their artifacts with others. They are very possessive about it. Admit it. It's the ego problem in the programmer. So before we end this lecture, I would like to show you some preconditions that must be followed in order for us to have a successful inspection process. We're looking at 6 preconditions for inspections. Number 1, most importantly, clear and visible management support. Number 2, a defined policy. Number 3, good training for all. Number 4, effective procedures. Number 5, proper planning. And number 6, adequate resources. So these are the 6 preconditions that we must follow, that every company must follow in order to have successful software inspections. You have seen the data that inspections work very effectively. This is the case that I wanted to make today for you. We will continue our discussion on software inspections in the next lecture. See you then.